Hello guys, this is Professor Shrenik Shah welcoming you to your very own channel PhysicQ for NEET and JEE exams. Guys, many of the students, especially PCB students, those who are planning to give their exam NEET, they always ask me, sir, why maths is so important for physics? Then I have always answered them, the only reason for maths being so important is because of the numericals and numerical type MCQs which you are going to face in your NEET exam. So guys, all those who are PCM students, they actually do mathematics in their syllabus itself. But all those PCB students, to become very strong in physics, you have to be strong in maths, at least certain part of it, which you are going to use in the numerical part and the MCQ part of your NEET exam. So guys, today's video is basically based on this mathematical journey which we are going to take only for those who actually need the help in mathematics to be good in physics. So if you are already well versed with the topic of mathematics, you may not watch the video, it's completely fine. But if you need help in mathematics to understand how to apply it in physics, then you should watch the video till the very end, because I'm going to make this video in three parts. And in those three parts, I'm going to cover first the trigonometry, second the derivative, and third, the most difficult of all, integration. Yes guys, these are the three major topics of mathematics which is very much required for you to apply and understand and solve numericals and MCQs for your physics as well as some part of chemistry. So guys, let's start with the first part, trigonometry. And believe me guys, I'm going to go with the real basics for you so that it is going to help you to understand each and every part of it. Okay, so let's start with it. So guys, the first thing to understand in trigonometry is basically all the terms which we have in the trigonometry part, and they are sine theta, cos theta, tan theta, cosec theta, sec theta, and cot theta. So guys, these are the 6 terms you will always encounter in trigonometry. So if you find any of this term, please understand that it is the trigo part which you need to be very much aware of. You are going to use that part anyhow. Okay. So first I need you to understand what exactly this means by. So let's say if you have a triangle, a right angle triangle, where you have the vertical side as say A, the horizontal side as say B, and the hypotenuse side as say C. And let's say this angle is 90 degree, as you can see, and let's assume the angle between the hypotenuse side and the side B as theta. Okay, so here we are going to apply this particular 6 names to this and understand what this exactly mean. Here, first thing, the most common thing which we use, and that is sine theta. The sine theta in this triangle means the opposite side upon the hypotenuse side. Yes guys, the opposite side upon the hypotenuse side. Now the question arises, what's opposite and what's hypotenuse? Nothing understanding. Sir, kuch nahi samajh raha hai. Guys, it's really simple. Try and understand this part. Opposite, I mean opposite to the angle theta. The side opposite to the angle theta, which you can see is nothing but A. Yes, so the numerator over here will stand for A. And the hypotenuse side, which means the hypotenuse side of the triangle, which over here stands for C. And so we are going to get the ratio as A upon C. So guys, once you understand sine, then the cosec is not that difficult to understand, because cosec is nothing but reciprocal of sine. Yes guys, it is reciprocal of sine theta. So when you take the reciprocal of sine theta, then you mean that you are going for cosec theta. Okay, so that means 1 upon sine theta, which means the reciprocal of the formula also, that is going to be hypotenuse side upon the opposite side which means C upon A. So I hope this is quite simple for you to understand now. So now we can go for the second part, which is the cos theta. So guys, cos theta is nothing but the adjacent side upon the hypotenuse side. Yes guys, the adjacent side upon the hypotenuse side. Yes, if you understand that for this theta, even the hypotenuse is adjacent and even this B is adjacent. So what is to be taken as the adjacent? Definitely guys, we are already taking this side as a specific name, hypotenuse. Then we are not going to refer it as the adjacent side of the theta. Which means the adjacent side I am talking about over here is the one which is the adjacent to the theta and not an hypotenuse side. Correct? That means the adjacent over here will stand for B and the hypotenuse will stand for C. So basically cos theta for this given triangle is going to be B upon C. Correct guys? Now that way we can go for the sec theta. Like cosec was reciprocal of sine, the sec theta is reciprocal of cos theta. So that means this is going to be 1 upon cos theta. And that means as per the ratio it is going to be the reciprocal also, which is hypotenuse side upon the adjacent side. That makes it triangle wise it's going to be C upon B. Okay, so I'm sure this is pretty much simple for you to understand. Now guys, the tan theta is actually defined as the ratio of sine theta and the cos theta. So basically sine upon cos gives you tan theta. So I'm going to write tan theta as sine theta upon cos theta. If you actually try and take the ratio, I can say from this itself the hypotenuse side will get cancelled. Correct? And that's how we get opposite upon adjacent. So basically tan theta is opposite upon adjacent. And so opposite side to the theta is A and adjacent side to the theta is B. Which means we have the ratio as A upon B. Okay guys, this is quite simple now. And now we are going for the cot theta, which we can remember it as the reciprocal of tan theta or the ratio of cosec and sec theta. Either way, it's completely fine. It's the same thing. Okay. So if you go for the reciprocal of tan theta, we get this as cos theta upon sine theta, which is over here becomes adjacent upon opposite, and by the ratio of sides it's going to be B upon A. So whenever you have a triangle available with you with the sides given in the form of a right angle triangle, you should by default use this basic concept, this basic formulas for sine, cos and tan, or the reciprocals cosec, sec and cot respectively. And I also give you a hint or a simple way to remember this. That is how I remember as a student, that sine is O upon H, that's O. Cos is A upon H, that's R. And tan is O upon A, that is OA. So we have something like O R O A. So guys, you can repeat it with me. O R O A. O R O A. O R O A. Yes, that's your sine, cos, tan. O R O A. O stands for O upon H, opposite upon hypotenuse. R stands for A upon H, adjacent upon hypotenuse. And OA stands for opposite upon adjacent. That is what you get for all the three. Once you get all the three, then the reciprocal will go for cosec, sec and cot. So that becomes quite easy for anyone to remember that, guys. So please copy this so that we can go ahead with the better trigonometry formulas or more important trigonometry formulas or the more difficult ones. So guys, I hope you have already copied the entire table and entire part. Now what we are going for is even more important because this involves certain values which you need to remember. Okay, so please pay attention. Basically, I am making a table for the angle in degrees, then angle in radian and corresponding sine theta, cos theta and tan theta. Guys, I'm not asking you to remember the values of cosec, sec and cot for all the angles which I'm going to do, because that does not make any sense. As I already told you that the reciprocal of sine is going to be cosec, the reciprocal of cos is going to be sec, and the reciprocal of tan is going to be cot. So if you can remember these three values, you can by default within one step in your mind, you can derive the value of cosec, cot and sec. Okay. So now we go with the values in degrees first. We have say 0 degree, 30 degree, 45 degree, 60 degree, 90 degree, 180 degree, 270 degree and 360 degree. These are the most common values which are used. Okay, and that is going to help you to apply these values in multiple places. Okay, so if I just draw the lines. Okay, so we have got the table now. Okay. So let's go ahead. Now let's convert this angle in degrees from degrees to radian. Now very different or very easy thing I should say. The angle in radian is actually equal to pi by 180 into the angle in degrees. Which means whatever value we have in angle in degree, we just substitute and multiply it with pi by 180 and we get the value in radian. Okay, so that's a conversion factor we can say. So here, when you put 0 degree, I'm sure you understand 0 into anything is 0. So we have 0 radian over here. This unit is going to be rad. Okay, 30 degree if you put over here, 30 into 6 is 180. So we are going to get this as pi by 6. If you put 45 degree, so 45 into 4 is going to be 180. So you are going to get pi by 4. For 60 degree, 60 into 3 is 180. So we get this as pi by 3. For 90 degree, 90 into 2 is 180. So this is going to be pi by 2. For 180 degree, 180 and 180 gets cancelled and we get pi radian. Then for 270, basically it's 90 into 2 and 90 into 3. So numerator will be having 3, denominator will be having 2. So we are going to have 3 pi by 2. And last, if I put 360, 180 into 2 is 360. That gives us 2 pi. Okay. So these are the important formulas which you need to understand. Now after this, we are going to apply it for sine, cos, tan, the values. And please understand how I'm applying the values and how I'm making the table. Pay attention to that part because that's going to help you a lot. Okay. So I can say sine 0 is 0. Sine 30 is half. Sine 45 is 1 by root 2. Sine 60 is root 3 by 2. And sine 90 is 1. Okay, so this value I would recommend you to remember. Yes, sine 0, 0, sine 30, half, sine 45, 1 by root 2, sine 60, root 3 by 2, sine 90, 1. So please remember this. Now for cos, basically, if you reverse this values, you can fill up the cos. Yes, guys, if you reverse this value, you can fill up the cos, which means 1 over here comes here. Root 3 by 2 comes over here. 1 by 2 remains as it is. Half goes over here and 0 goes over here. So basically sine and cos you can say are complementary. So they just flip the sides. But only applicable till 90, yeah guys. That's like a first quadrant. I'm sure you know what is quadrant, right? 0 to 90 first quadrant, 90 to 180 second, 180 to 270 third, and 270 to 360 is fourth quadrant. So here I'm not taking the quadrants values, I'm just taking the extreme of the quadrants, correct? And that is why I'm going just with the quadrant first quadrant ka table. Okay? Now, I guess once you make this, then the tan becomes so simple because tan is the ratio of sine and cos. So guys, 0 upon 1 is going to be 0. Half upon root 3 by 2 is going to be 1 by root 3. 1 by root 2 upon 1 by root 2 is going to be 1. Root 3 by 2 upon half is going to be root 3. And 1 by 0 is actually not defined or infinite. Okay guys? So I guess now this first quadrant values is quite simple for you to understand. So now we go for the remaining part, and there is a shortcut or a trick for you to understand over there also. So pay attention. Whenever you go from any angle to 180 plus, I repeat, whenever you go from any angle to 180 plus, the value remains the same, only the sign changes. I repeat, the value remains the same, only the sign changes. Which means, if I go from 0 to 180, I guess the value remains the same, only the sign changes. For 0, it does not make any difference because 0 then will remain 0 only. Similarly, if you add one more 180 to it, again the 0 remains 0, but there is no sign difference because 0 does not have a positive or negative sign. But now pay attention to the second one, where we have 1, for 0, for 180, when you add 180 to it, the value becomes opposite, which means negative 1. Yes guys, negative 1. And similarly, one more 180 you add, which means you go from 180 to 360. That's a flip basically. And that will give you again positive 1. And one more thing we have, if you understand over here, 90 and 270 have a gap of 180, which means whatever is the value of 90, if you want to add 180 to it, the value again changes from positive to negative or from negative to positive. So basically over here we have the 1 for 90, for 270 it becomes minus 1. Similarly for 0, it remains 0. So guys, did you notice? It's so simple. With 0, if you add 180, you flip the value. Then again you add 180 to make it 360, you again flip the value. So single flip for 180, double flip for 360. And similarly from 90 to 270 it is also 180 plus, which means again you flip the value. Now once understand about this flipping things, then again you have to just take the ratio for tan. And that's going to be 0 by 1 is basically 0. 1 by 0 is infinite. And 0 by 1 is again 0. So guys, even if you apply it for tan, it's quite simple, quite obvious, because 0, 180 degree add, still remains 0. 0, 180 one more time add, still remains 0. And infinite for 90, if you add 180 to that angle, 270 again remains infinite. So guys, this table is very much important. I would also say that if let's say you have to find something like cos of 225, just take a random value, cos of 225. Now definitely we know cos of 45, right? Cos of 45 is 1 by root 2. And if you add 180 to that 45, you get 225, which means cos of 225 is going to be exact same as cos of 45, but with the direction or the sign being flipped. Which means if you have 1 by root 2 for 45, for cos 225 it is going to be minus 1 by root 2. Yes guys, I hope you understand. It's quite simple. You just have to remember the tactics to remember it. Okay, so please copy this table. It's very, very important. So guys, I hope that you have copied the table because that table is quite important. Now we are going for further complicated part of trigonometry. So now please pay attention to this. Now we have something like sine of x plus y, which means sine of two angles, the sum of two angles. In that scenario, we have a direct formula for it, and I would advise all of you to just remember it. You don't have to understand the derivation of it, or you don't have to even understand how this formula came up, because this formula itself is important and not its derivation. Okay, so we have sine of x plus y as sin x cos y plus cos x sin y. So we have sine as sine cos, cos sine. That's how you need to remember. Yes, sine of x plus y as sine x, sine cos, cos sine. So sine x, cos y, cos x, sine y. And instead if you sine, you have cos. Then the formula becomes cos cos sine sine. Yes guys, cos cos sine sine. Cos x, cos y, sine x, sine y. But in case of sine, you have addition between the two. In case of cos, you have subtraction between the two. Which means sin x cos y cos x sin y is going to be sine of x plus y, and cos x cos y minus sin x sin y is going to be cos x plus y. And again, if you take the ratio of this two, you get tan of x plus y, and when you take the ratio and simplify this, you get something like this: tan x plus tan y upon 1 minus tan x upon tan y. So plus and minus, I hope you understand, it's quite obvious. The plus has to be in the numerator because sine is going to be in the numerator. Minus is going to be in the denominator. So we get this: tan x plus tan y upon 1 minus tan x into tan y. Now what if I get, guys, we have subtraction of the two angles. Like, what if we have sine of x minus y? So guys, the formula remains almost the same. The only thing which changes we have is sin x cos y cos x sin y. The only thing in between we will have is a minus sign instead of plus. And similarly, that means the cos of x minus y will also be remain the same. We'll have cos x cos y minus की जगह पे plus sin x sin y. Correct? And so automatically even the tan x minus y will have the flip over its sign. We are going to have tan x minus tan y upon 1 plus tan x into tan y. So guys, this is very important, and remember, this formula you may not use directly in physics, but indirectly this formula is going to be used. I'll give an example for that. Let's say I want to find sine of 2x. Yes, sine of 2x. Can I say sine of 2x is as good as sine of x plus x? Which means we have x plus x, I can apply this formula. Right? So sine x cos x plus cos x sin x. So basically, if you actually understand, it's like 2 times sin x cos x. Yes guys? So that's why we have sine 2x as 2 sin x cos x. So it becomes quite easy for us to understand, isn't it? Now if you apply cos 2x, can I say I'm going to apply this formula and I'm going to take everything as x. So we're going to have cos x minus sin x sin x. Now cos x into cos x is cos square x, and sin x into sin x is sin square x, which means we have cos 2x as cos square x minus sin square x. So that's the formula for cos 2x. And guys, here I'm going to introduce some important formula which you can use over here as a shortcut. Yes, and that is the sum of squares of sine and cos. Sine square x and cos square x is always 1. Okay, this is very important, guys. Sine square x plus cos square x is equal to 1. So in that scenario, can I write cos square x as 1 minus sine square x? And if I put that 1 minus sine square x, we have 1 minus sine square x minus sine square x, which means we are going to have 1 minus 2 sine square x. You might need this formula in case of if you require everything in terms of sine. So you can use this. Other way around is also possible. You might replace sine square x over here as 1 minus cos square x. So we are going to have cos square x minus, in the bracket, 1 minus cos square x. So the minus cos square x becomes positive and gets added over here, and we have the formula as 2 cos square x minus 1. So guys, now you need to understand over here that whenever you need a formula, that formula might be in the form you have already learned, or they might give you the formula in a way you might not have learned. जैसे कि if I give you a simple example, Instead of giving you cos 2x in any numerical or MCQ, I might give you cos square x. So how you are supposed to think over it? Can I not write cos square x is equal to 1 plus cos 2x the whole divided by 2? Think over it. I can take this minus 1 over here, makes this as 1 plus cos 2x as 2 cos square x, and 2 in the denominator, and I end up getting this formula. So guys, it is very important that when you remember the formulas of Trigo, you remember or you understand to apply it both ways, not always and only from left to right. It means when I say sin x plus y, you remember it as sin x cos y plus cos x sin y. So wherever you see sin A into cos B plus cos B into sin A, or sorry, cos A into sin B, whenever you encounter that, you need to make sure that you understand that you have to apply this formula in the reverse order, because that is the most important part in trigonometry. They will not give you always the formula to be used from left to right. They might give you the formula which is used from right to left, and that also you need to pay attention to, because that is only going to help you guys. Okay guys, so ये बहुत important है. This is very much important. Now one more thing I'm going to do over here, there's a certain variation to try out. What if I divide this entire equation by cos square x? Yes, I divide the entire equation by cos square x. So sin square by cos square. Let's say quickly. Yes, 10 square x. So we have over here 10 square x plus cos square x upon cos square x. Yes, it should be 1 obviously. And on the right hand side we have 1 upon cos square x. Guys, the reciprocal of cos. Quickly. Yes, sec. The 1 upon cos square is going to be sec square. We have sec square x, which means 1 plus 10 square x is sec square x, or you can write 1 just as sin square plus cos square hai. Similarly, 1 can also be sec square x minus 10 square x. Correct? I hope this is not going too fast for you. Guys, all the PCB students out there, I'm sure you are enjoying this part of mathematics, because this part is something which you're going to use a lot number of times in the MCQs and numericals. Okay? And similarly, just say here I have divided over here by cos, right? I can also do that same thing for sine. So what if I divide by sine square x quote? Yes, I get the third version of it. Come on. Sine square x upon sine square x. Come on. Yes, it's simple. 1 plus cos square x upon sin square x. Guys, cos upon sine was cot. The square of it is cot square x. And we are going to have 1 upon sin square x. The reciprocal of sine was cosec. The square of it is going to be cosec square x. So basically 1 plus tan square x is sec square x, and 1 plus cot square x is cosec square x. You got 2 more versions of this formula itself. So guys, what you need to understand over here is, when you encounter certain trigonometric function in your question, you need to understand that in what format it has been given. Is it in the form of a square, or is it in the form of a double angles? Is it in the form of sum of 2 angles or difference of 2 angles? Based on that, you have to understand, because यहाँ पे you can also have like product of sine and cos, cos and cos sine, or cos and cos sine and sine. And there is one more variation to it. Okay, so we are going for that, but please understand this, all the formulas with all the versions, you need to remember it, guys. So please copy this. So guys, I hope you have copied the entire formula, and as you can see, I have not rubbed this part, the sine of x plus y and sine of x minus y, or cos of x plus y. Because the next formula which I am going to deal with you, many of you get confused between this version and the other version. So guys, please pay attention with the next 4 formulas I am writing. They are quite important. We have sine of x plus sine of y. We have sine of x minus sine of y. We have cos of x plus cos of y. And we have cos of x minus cos of y on the left side. So now guys, the confusion stays over here that we have sine of x plus y as a whole, many of you start thinking it is same as sine of x and sine of y. Guys, it's quite different. Please understand. The sine applied to the sum of all angles and the sum of sine of the two angles. That's quite different. Correct? So please understand, it is the sum of angle and the sine has been applied to that whole angle over here. Whereas over here the individual angle sine has been applied already and then you are adding it. So they are quite different. Please don't get confused with that. Okay. So now we have sine x and sine y, where we have the formula as 2 sine cos. Yes, that's a pattern you remember. For sine x minus sine, you will take it as 2 cos sine. Then for cos x and cos y, positive, the addition, 2 cos cos. And last, cos x minus cos y, for the minus sign, you have minus 2 sine and sine. So this is what you need to remember. Sine x plus sine y, sine plus sine is sine cos, 2 sine cos. Sine minus sine, 2 cos sine. Cos plus cos is 2 cos cos. Cos minus cos is 2 sine sine with a minus sign. Guys, now what is there in the angle? For the first term, it is always x plus y by 2. Yes guys, x plus y by 2 everywhere. And for the next part of the angle, it is always x minus y by 2. Yes guys, x minus y by 2. Yes guys, this you need to remember, because when you are going to use the trigonometry in oscillations, you are going to encounter a type of numerical for superposition of waves. And in that scenario, you might encounter the addition of 2 sine or sine and cos or 2 cos. Okay, even the subtraction of the two. And that is where it's going to help you a lot. Okay, so this is something which you need to remember. Okay, so here when you have the addition of the 2 sine, it's 2 sine cos. Subtraction of the 2 sine, it's 2 cos sine. Addition of the 2 cos, it's 2 cos cos. And subtraction of the 2 cos is minus 2 sine sine. The first angle always is x plus y by 2 and second angle is always x minus y by 2. Now what if, guys, what if I want to go the other way around? Because when they will give me this as a question, they are going to give me, might be something like sine of C into sine of D. So somewhere over here, or I just make the first equation itself to avoid any confusion. Sine of C and cos of D, or cos of C sine of D, or cos of C cos of D, or minus sine of C sine of D, something like this, which means they are given the right hand side if you can concentrate. And in this scenario, the x plus y by 2 is C and x minus y by 2 is D. So we have to get this expression in the form of C and D. So that's going to be quite interesting, guys. Now pay attention. If I take C as x plus y by 2 and D as x minus y by 2, don't you think if I add both of them, yes, if I add both of them, I get x plus y plus x minus y, the y gets cancelled, we get 2x upon 2. That's x, which means the x is going to be C plus D. So guys, we are going to have on the right hand side as sine of, instead of x, we are going to have C plus D. And instead of y, obviously we need to subtract the two equations. When we subtract it, it's x plus y minus x minus minus plus y. So x gets cancelled and y gets added. So it becomes 2y. 2y upon 2 gives you y. Which means we are going to have plus sine C minus D. Now guys, definitely you cannot forget that 2 outside, right? Here there is no 2 present. So you have to divide by 2 over here. Which means upon 2. So sine of C into sine of d becomes your sine c plus d plus sine c minus d, the whole upon 2. Yes, sine c into cos d. So I guess now it's quite simple that when we have cos and sine, we are going to have sine c plus d minus sine c minus d, the whole upon 2. If we have cos and cos, we know it is going to be cos plus cos, where it is c plus d, and here it is c minus d divided by 2. And when we go for minus sine sine, it is again going to be cos and cos, cos c plus d minus cos c minus d, the whole divided by 2. Now guys, if you understand, these formulas have been made by using the basic fundamental principles which we have learned at the start. But if I try to explain those derivations to you, you are not going to be clear about it, because those derivations you are not going to use anywhere. But these formulas, yes, you are going to use in multiple chapters. If I just give you the names in which the trigonometric functions are going to use, I can say the first thing, oscillation. Second is wave motion. Third is electromagnetic waves. Fourth, electrostatic magnetism, EMI. Wherever you have electric and magnetic components, everywhere I can use this equation. Wherever I have the waves, even the light, the optics, not the ray optics but the wave optics, I can also use it over there. Which means these trigonometric functions are not going to be used in only one or the two chapter of physics. It's going to be used in multiple places. And that's the reason I'm giving quite a more importance to all of this. And yes, it's very important that you note this down everything, because this is going to help you as you need to remember this to solve MCQs. With that, I will just go for the last part of the formula. I would say the second last, because there is one more session coming up. Yes, and that is if I have sine 3x, yes, 3 times the angle, then the formula is 3 sine x minus 4 sine cube x. Yes, 3 sine x minus 4 sine cube x. Similarly, if we have cos 3x, then it is 4 cos cube x minus 3 cos x. So somewhat exactly you can say opposite of the thing. Yes, I would definitely like you to keep copying with it, because that is going to help you. So basically we have sine 3 sine x minus 4 sine cube x, and cos 3x as 4 cos cube x minus 3 cos x. Now definitely again, if you want, you can just take the ratio of the two to get the tan 3x value. But practically I can say that tan 3x value is not much of a use, because you will not going to use it in multiple places as such. Okay, so guys, I would definitely like you to copy this, after which we have just one last part left in the trigonometry part. Okay, please copy. So guys, now we are in the final part of it, and that is when you have the angle with a negative sign, what happens to the value? Yes, for sine of negative x, we have negative sine of x, which means we find the value of the sine of that angle and we put a minus sign for it. What if we have a negative for cos? It doesn't matter, it just remains the same as cos x. So minus sign hai, nahi hai, doesn't make a difference. And tan of minus x, definitely, because it's the ratio of the two, it's as good as the ratio of this two. So minus sign upon cos is definitely going to give you minus 10x. Okay, so guys, this is the final list of the formula. I guess I've given you enough number of formulas for this. Now, in the next 1 or 2 minutes, I just want to discuss some of the applications which is going to help you out. How to solve a certain trigonometry formula or certain trigonometric questions with the help of the formula we have done. The simplest example which I can give you, one of it is, let's say I want to find sine of 150 degree. Now if you remember the table which we have done 0, 30, 45, 60, 90, 180, 360, 270 and 360, correct? Which means we have not done of 150. So can I just make this sine of 150 as sine of 90 plus 60? Yes, because 90 plus 60 is 150. Now we do remember the formula as sine of x plus y, as sine x cos y plus cos x sine y. Yes guys, here the x is 90 and y is 60. So let's substitute. This will become sine 90, this will become cos 60, this will become cos 90, and this will become sine 60. Now we know the values, remember? Yes, sine 90 from the table. You can just have a look at the table right now. But yes, you need to remember that value, okay? So sine 90 is 1, cos 60 is half, cos 90 is 0, does not matter whatever the sine 60 is going to be, but still sine 60 is going to be root 3 by 2. Correct? So it's basically 0 into root 3 by 2 is 0 and 1 into half is half. So guys, we got the answer. It's that simple, isn't it? So sine of 150 is also half, similar to cos of 60, because everything else was either 1 or 0. Correct? So this is very simple thing for us now. Whatever angle they give you, you can just differentiate or divide it into two parts which you are aware of. And don't worry, they are not going to give you something like angle 121 or 119 or maybe 39 or something like that. Don't worry about that, because that's not going to happen. Reason why that's not going to happen is because when they give you the angle, and if they want you to find the values, they need to give you the table of sine table, cosine table and tangent table, if the value is apart from the round of values. Okay guys, let's take one more example and try and understand how to do that. Let's say, for example, cos of 120 I want to find. Now instead of dividing this 120 into some other angle, I can make this as cos of 2 times 60 degree. Isn't that cos 2x? Yes guys, the cos 2x formula, we have three versions if you remember. First version, cos square x minus sine square x. So I can write this as cos square 60 minus sine square 60. There was another version if you remember, that was 1 minus 2 sine square x. So I can also write this as 1 minus 2 sine square 60. And there is a third version if you remember, that was 2 cos square x minus 1, which means I can also write this as 2 cos square 60 minus 1. Now you might be thinking, sir, what's the benefit of remembering these three versions? Guys, don't you think during the exam, let's say you remember all the three versions, but you don't remember all the formulas or all the values. What happened? You don't remember sine 60, but you do remember cos 60. Don't you think you can use this version and still solve the sum? Are you getting my point? So that's going to help you out. To remember more and more version is just going to help you out, guys. So please remember that and always try to remember all the possible versions given. Okay? So in that scenario, let's say we use this one. Okay? So cos 60, if you remember, it's half. The square of that is going to be 1 by 4 minus sine square 60. Yes, sine 60, if you remember, what's root 3 by 2. The square of that is going to be 3 by 4. Now I'm sure you understand 1 minus 3 is going to be minus 2 by 4. That's going to be minus half. That means cos of 120 degree is minus half. Now you might be thinking, sir, if you remember, whenever you add 180 degree, the value becomes opposite, means the sign becomes opposite. That's what you said. But here, when you add 120 to 60, that does not become 120. 160 and 180 becomes 240. So cos of 240 should be minus half, because cos 60 is half. Definitely cos 60 is half, and cos of 180 plus 60, that is 240, is also minus half. But yes guys, cos of 120 is also coming as minus half. I have not mentioned that, or I have not said that when you add a 60 it does not turn to minus or something. Okay, so here you are not applying that logic of flipping the values by adding 180, because here we are not adding 180 to this. Okay guys, so don't get confused by mixing the formulas. Okay, so here I can definitely say that from my side, I have done almost everything which was required for you to understand, remember, and memorize all the formulas which is required for trigonometry. So guys, it's a request. Please make a list of all the formulas in your notebook, and if possible, give vivas to your parents or to your siblings or to your friends. By memorizing these formulas only, you can solve all the formulas or all the MCQs related to trigonometry. Okay guys, so please copy this, and if you like the video, please hit the like button and subscribe to our channel, because we are coming up with more and more videos guys. Okay, thank you everyone.